Hi, welcome to my video on rational expressions and word problems. And part one of the word problem is going to be on the work rate problems. Let me explain the work rate problems, the way I handle it. Work rate word problems. The number of units times the unit rate equals what's done. That's the job completed. And when we say what's done, we mean one job. Job is completed, one. Let's look at the statement. Person A can paint a room in 90 minutes. That means in 1 minute, person A will do 1 over 90 of the job. Let's say the person will do work for 10 minutes. Therefore, 10 times 1 over 90. 10 and the 90 goes 9. In 10 minutes, the person will do 1/9 of the job. A truck can fill a hole in the ground with 8 loads. Therefore, one truck will do 1 load, or one truck will do 1/8 of the job. So if the truck does 4 loads, then it'll be 4 times 1/8. 4 and the 4 goes once, 4 and 8 goes 2. So if the truck delivers 4 loads, he'll have half the job done. An open valve can empty a tank in 6 hours. That means in 1 hour, the open valve will empty 1/6 of the tank. And if it works for 4 hours, it'll do 4 times 1/6. 2 and the 4 goes 2, 2 and the 6 goes 3. So in 4 hours, you'll have 2/3 of the job done. So that's the way I'm going to work out my problems. I discovered this is the way I like it. Let's see if it makes sense for you. Try it. Let's do some examples. Person A can paint a room in 40 minutes. That means person A will do, in 1 minute, will do 1/40 of the job. Person B, in 1 minute, will do 1/60 of the job. So 1 minute is 1/60. Let's work on number 1. If both start painting the room together, when will they finish the room? So I'm going to let X be the number of minutes working together to do the job. Okay, here we go. So if they're working together, that means that person A will do 1 over 40 of the job. Person B will do 1 over 60 of the job. So here they are working together. So how many minutes, gotta be careful, how many minutes will they both work together to do the job, which is 1? And so to work this fraction, I'm going to get an LCD of 40 and 60. LCD for 4 and 6 is 12, so I got 120. So I'll convert the 40, multiply it by 3 over 3. That gives me 3 over 120. Multiply the 60 by 2 over 2. That will give me 2 over 160. 2 over 120. And if I add, I get 5 over 120. And 5 over 120, 5 into 5 goes once, 5 and 120 goes 24. And so multiplied by x, x is over 1, so x times 1 over 24 is x over 24 equals 1. And again, if I let 1 equal 1 over 1, cross multiply, 1 times x gives me x, and 1 times 24 gives me 24. So working together, it'll take both of them 24 minutes together to do the job. Okay, let's look at another scenario on the same problem. I wrote down the unit rate for person A as 1 over 40. Unit B is 1 over 60 because I'm using the same problem as on the other page. Person A paints the room for 10 minutes and stops. Person B finishes painting the room. How long did person B take? So I'm going to let X be the number of minutes to paint the room alone. Okay, so if person A works for 10 minutes, that means person A will do 10 times 1 over 40. So this is how much work or how much of the job person A has done. Now, person A stops and person B starts. So person B works at a rate of 1 over 60 for X number of hours. And when these two, this person A works for 10 minutes and stops, this person B works for X number of minutes and the job is done. So that's the whole job completed. So 10 times 1 over 40, it cancels and I get 1/4. And X times 1 over 60 is X over 60 equals 1. Now you can see that the LCD is 60. So I multiply each part of the equation by 60. So every denominator should cancel now. So 4 into 60 goes 15. So that's 15. 6 cancels into 60 cancels into 60 once. So that's an X. And 1 times 60 is 60. So X equals 60 minus 15. So X is 45. So it takes person B 45 minutes to finish the room working alone. Again, the key is that person A works for 10 minutes, so you can see that's 1/4 of the room done. And so notice I added what person A did to what person B did. A little bit different than the first one. Let's do B. A swimming pool needs water. A large truck can fill it with 12 loads. A small truck can fill it with 18 loads. Working together, how many loads for each truck will fill the pool if 2 large trucks and 3 small trucks are used? Well, the unit rate, let's use the large truck. Let's use large T. If the large truck does it in 12 loads, then it'll do 1/12 to the job with 1 load. And the small truck does 18 loads, so a small truck will do with 1 load 1/18 of the job. So, working together, how many loads for each truck will fill the pool if 2 large trucks and 3 small trucks are loaded? So if you use 2 large trucks, then you're going 2 times 1/12. That means that you have 2 over 12. You have 1/6 to the job done. If you're going to use 3 small trucks, you're going to use 3 times 1 over 18. And that's 3 over 18, or you can cancel to get 1/6. So notice the 2 trucks are doing the same. So if they work together, so the 2 large trucks will do 1/6 to the job. The 3 small trucks will do 1/6 to the job. So we want to know if they work together, how many hours, or how many loads will it take both of them to do the job? And so 1/6 plus 1/6 is 2/6. And that works out to be 1/3. And we put the X over 1, so X times 1 is X. 3 times 1 is 3 equals 1, and 1 is 1 over 1. Cross multiply. X times 1 is X. 3 times 1 is 3. So when each of these 2 trucks and 3 small trucks do 4 loads or 3 loads each, then the job will be done. So 3 loads is the answer for, again, 3 loads for each of the 2 large trucks and the 3 small trucks will have the job completed. Hopefully it's making a little bit more sense. Let's do a couple of more examples. But this is a practice. Practice means you can pause your video and write down this problem, work it out, and then when you get it done, press play to see if you're got it done right. So, 3 trucks are filling in the ground for a building. Each truck can do the job alone with the number of loads stated below. So the truck A works alone, he does it in 60 loads. Truck B working alone does it in 30 loads. Truck C, if worked alone, can do it in 20 loads. But that's the unit rate for each of those. Truck A will do 1/60th of the job with one load. Truck B will do 1/30th of the job with one load. Truck C will do 1/20th of the job with one load. So the question is, if all the trucks are used to fill in the ground, how many loads would each truck do? So we're going to let X be the number of loads when they all work together to do the job. So here we go. So if they're all working together, that means truck A will do 1/60th of the job, and truck B will do 1/30th of the job. Truck C will do 1/20th of the job. And if they're all working together, how many hours, or how many loads, I say hours, how many loads will it take with all of them working together to finish or do the job? And we have to get an LCD for all these fractions. So an LCD is, I could multiply X by all of these and then multiply by the LCD, or I can work out the inside of the bracket. So the LCD is 60, because 3 and 2 has a multiple of 6, so 60 is the denominator that all these will divide into. So that means 60 is okay, 30 is going to be multiplied by 2 over 2, and 20 is going to be multiplied by 3 over 3. So X, that's 1 over 60. Multiplying by 2 gives you 2 over 60. Multiplying by 3 gives you 3 over 60. And if you add all them up, common denominator is 60. You get 1 plus 2 plus 3 is 6. And 6 over 60 is 1/10. And over here, X over 1 times 1/10, 1 over 1. So X over 10 equals 1 over 1. Cross multiply, X equals 10. So it takes 10 loads for each of these trucks to fill that hole when they're all working together. So the answer is 10 loads for each truck. And we have another one. Number 2, an inlet valve fills a water tank in 4 hours when empty. An outlet tank empties the tank in 6 hours when full. The tank is empty. So, as it's explained, the inlet valve does it in 4 hours to fill the tank. The outlet valve can empty the tank in 6 hours. Now the tank is empty. So there's no water in the tank. Both valves are opened at the same time for 6 hours. So what we have is the inlet valve is open, the outlet valve is open, the tank is empty, so it's going to be filled up. Notice the inlet valve has less hours than the outlet valve, so if it didn't, it wouldn't fill up. So both valves are open for the same time for 6 hours. Then the outlet valve is closed. Find the time for the inlet valve to fill the tank. So we have let's say the inlet valve. Inlet valve will fill the tank in 4 hours, so it'll do 1/4 of the job. The outlet valve can empty the tank in 6 hours, so in 1 hour it'll do 1/6 of the job. And the tank is empty. Both valves are open at the same time, so both of them are open at the same time for 6 hours. Okay. Now, if both of them are open for 6 hours, okay, here's 6 hours times both of them. But the inlet valve, I have to subtract the outlet valve because the inlet water is coming in, the outlet water is going out, so that's the difference in their work, how much they can do in 1 hour. But there's 6 hours times what these two valves are doing. And then the outlet valve is closed. Okay, so the outlet valve is closed, so the tank is going to fill up. So how many will it take for the inlet valve is, I'm going to let X be the number of hours to fill the tank for the inlet valve. Inlet valve. So the inlet valve works for 1/4. So how many hours at this rate will the tank be filled? So notice the little difference here. I have 6 hours, these working, but I can't add these because this is filling it up, this is taking it away. And the outlet valve is turned off. So after the outlet valve, after 6 hours, then the inlet valve is going to keep filling it up. So let's see what we have. Common denominator here is 12. So it's 4 into 12 goes 3, 3 times 1. 6 into 12 goes 2, 2 times 1 is 2. And x times 1/4 is x over 4. And 6 times 3/12, subtract 2/12 is 1/12. Take our time and do. And 6 into 12 goes 2, so I got 1/2 plus x over 4 equals 1. Notice I have a fraction, so I multiply by the LCD, which is 4. 4 times all these fractions will eliminate the denominator. 2 into 4 goes 2, so I get a 2. 4 into 4 goes once, so I get an x. And 1 times 4 is 4. So x equals 4 minus 2, so x is 2. So it takes the, after both valves are open for 6 hours, then it'll take the inlet valve 2 hours to fill the tank, working alone. Again, notice a little bit different how it's done. So I had to subtract here, multiply by 6, and then this inlet valve was working for a certain number of hours at this rate to get the job done. Hopefully, a little bit explaining on the work rate problems to get the job done. Hopefully, you have a little better understanding of the work rate problems if the teacher is giving you any, or if they haven't given you any in the grade that you're in, you might see them later on. They're normally in the math course somewhere. And if you like my video, click on the like button, click on the subscribe button, click on the notification bell. More videos are coming your way. And visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.